Right, this is Unit 2, Lesson 1, Fractions and Decimals. So our lesson essential question for this unit is what happens when you add, subtract, multiply, and divide rational numbers? So in this lesson, you'll learn to write fractions as terminating or repeating decimals and compare fractions and decimals. So first, we're going to write fractions. Some fractions like 1/2 and 3/4 can be written as a decimal by making equivalent fractions with denominators of 10, 100, or 1,000. However, any fraction a over b, where b can't be 0, can be written as a decimal by dividing the numerator by the denominator. So a over b equals a divided by b. The decimal form of a rational number is called a repeating decimal. If the repeating digit is 0, then the decimal is a terminating decimal. So example 1, write 7/8 as a decimal. You can use paper and pencil, or you can use a calculator. Either way, you're going to get 0.875 when you divide 7, my numerator, by my denominator. So 7 divided by 8. Okay? We're going to write each fraction as a decimal, 4/5. So I take 4 divided by 5. This gives me 0.8. I'm going to do the same for 3/16. 3 divided by 16 gives me 0.1875. Because these both eventually end in 0, if I continued this out, I'd have 0.80. This is a terminating decimal. Same with 1b, 3/16. Not all fractions have repeating digits that are 0. Okay, sometimes a non-zero digit or group of digits repeats without end in the quotient. So for 1/6, I divide 1 by 6, and I get 0.166. If I keep going, I'm going to continue getting 6s forever and ever and ever. Now, if you put that in a calculator and do 1 divided by 6, you'll get 0.1 with a bunch of 6s and then a 7. Okay. Calculators automatically round the last digit that's shown on the calculator, but it still is going to continue 6s forever. Okay. You can indicate that the digit 6 repeats by annexing dots, so 0.1666666 repeating. This decimal is called a repeating decimal. Okay. Repeating decimals have a pattern in their digits that repeats without end. Our notation is a nup as a bar or line placed over the digit or digits that repeat. The table shows some examples of repeating decimals and their bar notations. So 0.16 repeating, I have 0.16. Notice the bar is only over the digit or digits that repeat. Okay. For 0.353535, notice the 35 is what's repeating, so I have 0.35. The bar is over both the 3 and the 5. For 12.68, where the 8 repeats, the bar is only over the 8, not the 6 and the 8, just the 8. For the last one, 5.71428, 571428. That's what's repeating. That's 714285. I know it seems like a lot of digits, but that's what's actually repeating. So that bar is going to go over those amount of digits. Example 2, write each fraction as a decimal. Use a bar to show a repeating decimal. So I have 5/12. I divide 5 by 12, and I get 0.416. The 6 is repeating, so I put a bar over the 6. For -2/11, I do 2 divided by 11. I get 0.1818. The 1/8 is what repeats. Okay, so I put the bar over 1/8. Okay. For -5/6, so I get -0.83. The 3 is what repeats. So you'd have a bar over the 3. Okay. For your homework, this is how you're going to write it because you can't actually draw a bar over the repeating digits. So tell me what you're drawing the bar over. So in this case, the bar would be over 3. For 7/9, 7 divided by 9 is 0.7, and that repeats, so bar over the 7. It is helpful to memorize these fraction decimal equivalents because they come up the most often. So 1/2 is 0.5, 1/3 is 0.3 repeating, 1/4 is 0.25. So you can think of 1/2, 1/4, 3/4 as quarters. 1/5 is 2/10 or 0.2. 1/10 is like a dime. So you're thinking about dimes. So a tenth of a whole or 0.1. 1/100th is 0.01. 2/3 is 0.6 repeating. 3/4 is 0.75. 2/5 is 0.4. 3/5 is 0.6. 4/5 is 0.8. And 5/6 is 0.83, where the 3 repeats. All right, so example 3. According to the USDA, teenage boys should consume an average of 2,700 calories per day. About 360 calories should come from milk. To the nearest hundredth, what part of a teenage boy's total calories should come from milk? So I'm going to divide the number of calories that should come from milk, 360, by the number of total calories that they should have per day. So 360 divided by 2,700 is 0.13. Notice that 3 repeats. So 0.13 with the bar over the 3. Look at the digits to the right of the thousandths place. Round down since 3 is less than 5. Milk should be 0.13 of the daily calories consumed by a teenage boy. All right, let's do a problem to find out. In a recent Masters tournament, Zach Johnson's first shot landed on the fairway 45 out of 56 times. To the nearest thousandth, what part of the time did he shoot? Did his shot land on the fairway? So I'm going to take the amount of times that he made the shot divided by the amount of total times that he took the shot. So 45 divided by 56. So 45 divided by 56, this equals 0.80357, and it keeps going, okay? But I was asked for the thousandths place. So this is the tenths, the eighths and the tenth, hundredths, thousands. So I'm going to look at the 3, and I'm going to look at the number right next to the 3, which is a 5. The 5 tells me to round up. So when I'm rounding, I get 0.804. Compare fractions and decimals. It may be easier to compare numbers when they are written as decimals. So for example 4, we're going to replace each circle with less than, greater than, or equal to make a true sentence. So I have 1/4 and 0.2. Okay. I recommend changing any fraction to a decimal before you're comparing them because it's easier to see the numbers when they're in decimal form to compare them. So I have 1/4 and 0.2. Well, 1/4 is equal to 0.25. I can add a 0 on the end of 0.2 to make them comparable because doing that doesn't actually change the value of 0.2. So if I look at 25 versus 20, 25 is larger than 20, so 1/4 is greater than 0.2. For B, I have -5/8 and -6/9. So I'm going to change both of these to decimals. -5/8 becomes 0.625 and -6/9 becomes -0.6 repeating. Okay. So looking at this negative, this 0.6 repeating, is farther away from 0 than -0.625. Okay, so that means -5/8 is larger than -6/9. So remember, for negative numbers, it's whichever one is closer to 0, that is the larger number. All right, so let's try it. I have 7/8 and 0.87. So I'm going to divide 7 divided by 8 gives me 0.875. And I'm comparing to 0.87. I can add a 0 on the end to look at this. So I have 875 compared to 870. Well, 875 is larger than 870. So 7/8 is larger than 0.875. For 4B, I have -7/15 and -5/12. So 7/15 is -0.46 repeating, and 5/12, -5/12 is -0.416 repeating. Okay. Well, if I add a 0 here, or a 6 there. So 416 versus 466. 416 is actually closer to 0. So that means this negative 7/15 is less than negative 5/12. So example 5, 30 out of 36 seventh graders and 34 out of 40 eighth graders participated in a marathon for charity. Which class had a greater fraction participating in the marathon? So I compare each. 34, 30 out of 36, so 30 divided by 36 is 0.83 repeating, and 34 out of 40 gives me 0.85. 0.85 is larger, so the eighth grade had a larger number of participants in the marathon. Let's try it. Over the weekend, 16/28 of the eighth grade girls and 19/30 of the eighth grade boys want to see a new comedy movie. Do a greater fraction of girls or boys see the movie? Okay, so I'm going to divide. 16 divided by 28. So 16 divided by 28 equals 0.57, while 19 divided by 30 is 0.63 repeating. Okay. So that means that the more boys went to see the movie. And that is the end of Unit 2, Lesson 1.